Alright, so we've got the part drawn, we've got our machine group. Let's go ahead in here. We are going to use the default tools today. It's CamInstructor, so we're going to use the default tools. We'll call it Lesson 4, in-class exercise. And I'm going to put threading there because that's kind of what we're covering, is that threading toolpath. We'll let it, since it's the in-class exercise and it's coming off CamInstructor, we'll give it our program number. Today's the 2nd. Oops. And we'll check mark our boxes. Remember, I just keep repeating it because I want to reiterate, I only check the assigned tools on the homework from CamInstructor. When you're using your tool library, because of the tool numbering that we're going to use, the way it's going to be set up in the machines, don't let it renumber those tools. Otherwise, you're going to be going out there, and when you realize that they're not in the right spot, you're coming back in here and have to change them all back manually. Okay? We are not changing them at the machine. And I say that because I get people that are like, oh, you can change these, it's okay. And they go changing them, and sometimes they don't get them right, and it really makes a mess out of the tool orientations and where everything's at, the station numbers. And then sometimes they change them and they don't change them back, and then the next person gets on there and something bad happens. Okay? We are not changing the tool numbers at the machine for the standard tools. Okay, it rolls. Those of you that do it in the summer, that rolls all the way through the summer too. Okay? If you have to take the tools out to put other stuff in for things we do during the summer, one of the tasks is when you get done, you reset it back up to the standard tool set. Okay, that's just the way we roll. It makes things flow. All right, overrides. We'll turn those on. We'll go ahead and edit the material designation. Not that it has any bearing other than putting the correct material type at the top of the program. That's the only thing that's doing for us. But I still always do that because if I give this to an operator, they don't know any better. You know, they might see 3 and 2 fluid end mills, but if that says steel there still, they might go to the rack and grab a piece of steel to cut the part. Okay, so we want to make sure they get good visual text information. Stock setup should be in the top plane. We're going to click on our properties here. This is 1'440". Let's make it out of 1 5/8 material. And the overall length is 3 inches, so let's just add 2 inches to that. Call it 5. And fit that. I've said it multiple times, but I just add 2 inches. Now, does that mean that I have to have exactly a 5-inch piece of material to go make this part? No, I might only be holding on to 1 1/4 inches. As long as I have the right amount sticking out of the chuck, it'll be okay. Now, the less I'm holding on to, the more, deflection I'm going to get. But I also might have a foot up inside the chuck, in the sleeve. We've got tube liners coming. Has anybody ever worked with tube liners on lathes, on CNC lathes? You know what I'm talking about? So we've got tube liners coming. We've got a company that reached out to me here recently. He's going to send us all these different size tube liners for the lathes out there, which what they do is you stick them inside the spindle tube, and they keep your material dampened to where when you ramps up to higher RPM, you don't get a bunch of vibration. So they just keep things concentric. I don't want to call it a collet, but it's basically just like a spacer sleeve that basically makes the spindle fit to the material so it doesn't vibrate real bad. Because if you do have 2 feet of material in there and it goes up to 4,000 RPMs, you might only have 2 inches out here, but that foot that's back in the spindle is going to still get to going on you. It'll make the room shake if you're not careful. Okay, we'll hit OK. Chuck jaws. Chuck jaw parameters, pretty standard here, from stock. And then our grip length is going to be our number that comes down here in our Z position. So 495, it's the positive number. You're going to type that number in as a positive and subtract your part length plus 1/4 inch. So 3 1/4. Oh, 1.7. Funny. That number keeps popping up, doesn't it? Okay. Now, that number only will pop up if you're using the add 2 with the 50 thou. You know what I mean? If you're adding 2 inches to your part length, and you're doing the 50 thou positive Z for the facing, that number will always be 1.7 if you do it all right. But if you change those numbers in the stock setup any, this number is going to change accordingly. All right. Mastercam gives no care about how much that material is up in the chuck. All we're really trying to do is tell it how much is sticking out of the chuck so we don't turn back so far and we hit the chuck. Okay. And I always tell everybody, if you're ever wondering, hey, how much do I need to leave sticking out? All you got to do is come in here and look at this number. If it's negative 3 1/4, you need to have at least 3 1/4 sticking out of your chuck when you set it up in the machine. Okay. Simple stuff. All right. We'll hit OK. We'll hit OK. And we should have our stock set up. I'm gonna hit save. Had a couple crashes yesterday, so I'm getting in. I'm finding myself hitting save more often nowadays because I'm seeing these new computers crash more often than the old computers. Not sure why. Those things are $1,879 a piece. They're an expensive computer, but I don't know. What's up? You drew your part in the wrong spot. So we always draw it. So how can you move it over? Move it over to the
translate.
Nope. What point you want to go there? There you go. All right, now go ahead. Right click, clear colors. Right click, clear colors. No, over, right there. Did you create a solid?
Yeah.
All right. What I'd like you to do is you're going to right click and go to import. I want you to go to your lesson 2 folder and import your lesson 2 in-class exercise file. Remember, you got to make it show your educational files down here, and then you're going to select your lesson 2 in-class exercise and hit open. That's going to give you these toolpaths. Once you get there, just stay there. Don't do anything until I tell you to, please. So everybody find their lesson 2 in-class file, okay? You guys shut your after we get out of this, shut your solid level off, just so it doesn't try to switch you over to solid chaining. All right, let's just couple things. I'm going to tell it to remember this file because we're going to take a toolpath at a time. We're not going to grab a bunch at once. Remember this file, assign current system, tool, and construction planes. And I kind of explained that a little bit yesterday, why I want to check that. There's been times where I've had assembly drawings given to me or assembly models, and like they come into Mastercam and I don't go in and move the parts all around. I just create new planes. So there's been times, I know for a fact, there's been times I've had mill and lathe parts that come in the same assembly model where I'll just shut the level off for whatever the mill part is, and then I'll create a new plane on the front nose of the lathe part, and then I'll program that lathe part wherever it's at in the graphics window, by creating new planes. Well, in that case, when I import my toolpaths, You know, I don't want them to all come in with top because I'm creating a new plane for that part. So I would want to check mark that to assign to whatever the plane is that I'm working in for that part. That makes sense. So I'm going to check mark that. I'm going to leave the other stuff all unchecked. We don't usually want it to calculate speeds and feeds. You know, if I've already dialed it in on another program, I wanted to bring those dialed in numbers to this other part that I'm bringing it to. Okay, so because usually I'm not going to pull tool paths from like an aluminum part to a steel part. You know, I'm going to kind of stick because I want the tools are going to be different to begin with. Okay, all right. So let's bring in this facing tool path. We'll hit OK, and then once it imports, we'll tell it that we're done. If anybody does have did create a solid, please just make sure your wireframe's on and just turn off your solid level. You don't have to delete it. Just turn it off for now. Okay, because we're going to work right off this guy. So for some reason, you know, if I try to hit regenerate here, you would think it'd just look at the stock and it would automatically do its thing. It doesn't. I don't know if that's a glitch or if it's just part of it. But you do have to go into the parameters. You know, and like I said, we're going to leave all this stuff to the defaults here. We'll go to face parameters. Everything we're going to leave just like it was in our other program. But as soon as we check mark out, it will generate the boundary points off of using the stock here. I don't know why. You would think it would just be able to regenerate and do it, but you have to go into the parameters, and then when you check mark out, it creates the 2 boundary points to generate the facing. All right. After we've got that, we can go and we're going to right click, import, and we're just going to bring in the rough toolpath. So toolpath 2 over here from that same file. We're going to hit import operations, and once it says it's done it successfully, we're going to hit done again. Okay, now this one's a little bit different situation. All right, because as soon as we get it in, it doesn't generate off the stock. It's got to have a profile, right? It's got to have a wireframe. Now, remember, you're just selecting literally the wireframe for what you're cutting on. Had a few people yesterday select the whole thing. You can't select the whole chain. You just want the upper profile that you're wanting to cut. Now, that doesn't mean this. That doesn't mean I want to go from here to here. Okay, it can do the front side, but it can't come back over here with the turning tool, can it? It's going to run right into the part. Or it will, but it'll crash. Okay, so when you select this, what I want you to do is I want you to pick the front chamfer here. Make sure the arrow's going the right way before you click the next end part. So the arrow needs to be pointing to the direction you want to cut. And then we're going to stop. I want you to pick this chamfer back here. Okay, pick this one back here and then hit OK. Now when you get to here, the second arrow should appear. My tool direction's the right way, my comp's the right way. If yours is flipped the other direction, anybody's flipped? No? Yeah? Are you on the air or are you just bobbing? You're just bobbing. If it is ever flipped the other direction, that means for some reason your toolpath you got cutter comp switched to left. All you got to do is right click and hit change side. That's all you're doing. When you hit change side, you're flipping the cutter comp from left to right. But you want that second arrow pointing to the correct side you want to be cutting on. Okay? We'll hit OK. Let's go into the parameters. We're not going to change anything on the first tab here. We're going to go to the second tab. Now, another thing that I want you to make sure, and if you got to write this stuff down, write it down. But you always want, I can't tell you any time I haven't wanted it to have stock recognition looking at remaining stock. Okay, that should be on remaining stock. All right, I want that on remaining stock. Now, the other thing, I'm leaving material for a finish pass. I got my depth cut up here. On my lead in, lead out, I'm coming in straight from the end of the part. I'm okay with that. It's going to cut that chamfer. On the lead out, I've got another 130 thou, so I'm going an extra 5 thou past what my part off tool. I'm going to use an 1/8 inch part off tool. So I'm going an extra 5 thou past the end of the part. I'm okay with that. Okay. Pretty much everything's there. Let's go back over here. Make sure stock update is checked. I had a few people yesterday, somehow stock update got turned off. I'm not sure if that was just an inadvertent click, but there was multiple people had stock update turned off, and that when stock update's not updating and you're trying to use remaining stock for your toolpaths, it doesn't work. Because if the stock's not updating for the next toolpath, it just tries to generate a toolpath based on all the stock still being there. Okay. We should be able to hit OK. It should regenerate. Mine did not. Why did not regenerate?
Nope, there we go.
Huh. Guess I have to hit the button. It should automatically regenerate when you hit OK, but mine did not. Did yours? Mine didn't. I don't know why. All right. If I hide that, you should see. Oops, not ghost. If I hide that, you should see the stock profile has been updated. Everybody good there? The little dashed lines closer to the part now. And that stock update can also be turned off if you accidentally inadvertently click right here. If you click there, it shuts stock update off. So try to pay attention as you're clicking and getting all click happy that you don't accidentally click and shut off stock update. If you get into a situation where toolpaths aren't wanting to generate and it's saying stuff like no entities found, or basically generating more toolpath than what you should know it should be doing, it's probably because stock update's been turned off or remaining stock's not selected. Okay, those are the couple little things there that you got to keep an eye on. All right, carrying on, we're going to go ahead and we're going to basically remachine down into here to rough this out. We're going to do this with the 55-degree tool. Now I'm going to tell you this on the part that I'm going to give you as an assignment, which is a lot like this part. You're probably going to have to go to a 35, not probably, you're going to have to go to a 35-degree tool. Okay, but you're going to use the ones out of the default library, so, but you're going to have to go to a 35-degree tool to get down into the features. I got asked yesterday about like a button nose turning tool. All right, so like a multi-directional button nose tool. Yeah, they're great. Lots of tool pressure. Anytime you got the bigger radius you have on the tool nose, the more tool pressure there is, so you fight deflection more. Most of the time, those button nose tools I only would use them if I need it to get into an area that I can't get into with my turning tool. So if I can't get in there with a 35-degree tool, then I might come in with like a button nose radius tool to do the roughing and the turning. A lot of times you've seen probably videos where they use them for like multi-directional, meaning they'll come in, they'll cut like this, then they'll go right back and just keep going in to the cut. That's another time if you're trying to remove material really fast, it doesn't have to go back and cut from the same side every time like a right-hand turning tool would. Okay. Don't drink that. All right, let's make a copy of this toolpath. Just trying to help out, baby. In the copy, let's go into the parameters, and let's select the 55-degree tool out of the library. So I think it's tool 1212, tool 12 offset 12. It should renumber it as tool 2. I'm not too worried about the feeds and speeds because we're using these default tools, so don't worry about that. Don't need to do anything there. Like I said, I'm only worried about feeds and speeds if I'm cutting apart. I'm not, unless I tell you, hey, and I will. I'm gonna give you guys a quiz next Thursday, I guess it would be for you. I'm going to give you a sheet and say, here's the parameters I want you to use for the tool. Use the default tools, but here's your cut speeds, here's your roughing feed per rev, here's your finished feed per rev. Plug all these in correctly. That's some of the stuff I'm going to check for. All right. So we're going to call this a re-rough because that's really what we're doing. We're coming in and re-rough. concave areas or recessed areas. A lot of time I say concave because I don't know, convex, concave. It makes sense to me. In industry, a lot of times people look at me like, "What are you talking? Like the recesses, like where it goes down into the part?" Oh, yeah, yeah. Or the negative X cuts, where you're plunging down in negative X. Okay. Rough parameters. I'm gonna back this off a little bit just because it populated that with a big number. With that tool, let's just go like 35 thou. Okay. Now, if we check mark out right now, it's going to throw up an alarm, right? It should. It's going to say no areas of remaining stock were found. Toolpath regeneration failed. Why? Because I didn't tell it to do anything different than what the other one did, right? And the fit with all plunge parameters shut off, the 80-degree tool can do it all. So I'm basically trying to cut air here, and it's like, hey, no bueno. So when I go back in and I go to those plunge parameters, I'll tell it I'm going to allow plunging in both directions. I'm going to give it front and back angle clearance of 3 degrees. It's just a safe thing. I don't fight. What's real bad if you don't give it that extra back clearance, Mastercam will try to take the tool edge right into sharp shoulders, and a lot of times you'll chip inserts. Okay, so I give it the front and back clearance angles just in case, like especially when I'm getting down in concave areas. Okay, I want it to have it on both sides. It will just prevent the insert from getting in there and loading up in a corner and breaking the edge off of it. All right. Once we do that, we check mark, we're going to get a collision, or we should, unless you've changed stuff already. Tool collision, continue toolpath. Yeah, I'm going to say yeah. Just tell it to continue all the way through. Until it gets to the end, it'll finish up. Now we've butchered the front edge of our part here. We've butchered the front edge of our thing here. But, I talked about that the other day, and I want to keep showing you it messed up so you remember how to fix it. Okay, that's that lead in direction, that lead in vector. 9 out of 10 times when you do a toolpath, sometimes it's you change the wrong geometry. I've had that happen to me, and I've seen it happen to a lot of students. Sometimes it's they just chain the wrong thing, but a lot of times, if you know the geometry's good, it's just I need to come in from a different direction. Most of the time with like these, I need to come down at that negative 135 degree angle. That way it's not trying to plunge down and go straight over into the cut. Now, why don't they make that intuitive? Why don't they make that intuitive? Well, they do. I say it. When you come in here, it's got this IntelliSet, and I can click on that. Oh, that's not what I want. That's going to crash again. We've got a collision. Make a liar out of me. Usually when you click on the IntelliSet, it will kind of, it's supposed to, look at the toolpath and prevent gouges like that. Sets the vector angle based on tool orientation. Choose this option if you know the vector angle is relative to the part. The angle dial points in the appropriate direction. My guess is it's not wanting to set it because what it's looking at is the start out here. So it's saying if this is where you're starting at, this will be your best, but it doesn't really know when you get in the middle. I bet you if I change it to just that concave chain, I'm going to do it real quick because I want to know. I think it'd be good for everybody to see. You just chill for a second. Don't do what I'm doing at the moment. I'm just going to chain that and see if I can see what it does here. Huh. Why is that still going to there? a second. Maybe it's this one. I thought IntelliSet was supposed to do it. Maybe it doesn't work very good. Let's see what automatically set it does. Look at that. Let me go back to the old chain and see what it does. Oops. Well, that does a good job too, doesn't it? So, you know, maybe you just turn it to automatic. Automatically calculate entry vector. I remember using the IntelliSet, but it's not doing what I recall it doing, which was looking at kind of the direction of the first cut, and then it would generate it. It would go like not negative 135. It would literally look at, and maybe mine's just messing up. I don't know. I don't want you guys to get too deep into it, but it would literally look at basically this approach direction, and it would, whatever that angle was that best made it go straight into that, it would grab that. So it really did that, and then maybe that's what automatic's doing now. So multiple ways you can make it work. You know, this works just fine too. Okay. All right. We have got it re-roughed. Everybody's do okay? No collisions now on the re-rough. Now, since it's aluminum, like I said, you know, the other day, I'm not real worried about the aluminum trying to dive down into these areas. I'm okay with that, but I do have a problem with one thing back here. I'm not far enough past the end of the part. Okay, by the extension that we did here, okay, the extension that we did here, when it gets back there and then it goes down at 45 degrees and I extend it 130, it's extending that out 130. So it's really kind of like a 45-degree triangle. It's only going about half the amount that I need it to in Z on that first pass. Easy way to fix this, and this is how I normally do it. Let's go back into the Expand Toolpath 2. Let's click on the geometry, and then right-click, Rechain All. And I just want you to, oops, unselect, partial chain. Go from the chamfer just to the straight part right here. Okay. All right. So we've taken this out. So it's not, this one's, we've taken this out of the equation here. It's 63 thou, right? So I'm going to add 63 thou to my lead out on this first roughing toolpath. So the 130, I'm going to add an extra 63 thou. So 193 thou to that one. I'll regenerate my other toolpath. There we go. Now I've got this, basically I've got this rough turn back far enough that my parting tool has got some clearance when I come in at the end and part that off. Okay. All right. I need a 5-minute break. Okay, now it's time to finish. So let's right-click, import our finish toolpath. I want to finish the same profile that I just did on my re-rough. So basically all I'm going to do is I'm going to take the geometry from toolpath 3 and I'm going to drag it down and drop it in the geometry for toolpath 4. And then I'm going to go into the parameters of toolpath 4. I'm going to grab tool 2, or my 55-degree tool. Maybe yours is a different number, but the 55-degree tool. In the finish parameters, I got to do the same thing with my plunge. I've got to tell it, hey, you can do it. Here's my clearance. So one of the things that you need to recognize, and I know that we've talked about it, everything in Mastercam is customizable, even the defaults for everything. We work off of pretty much the installed version of Mastercam. So the way, if you get Mastercam in industry and it's a new version and you're starting from scratch, it's the way all the things are going to be and the things you're going to go through and do. But all of this stuff, even like, and the reason I'm telling you that, like this clearance angle, some things that I do all the time, you can save into your default profile so that when you use that toolpath, you don't have to remember to go do that every time. So just keep that in mind that there's going to be a time where, and that's pretty similar. I know that works in Fusion and a couple other softwares that I've worked in, where you can set things up to you repetitively do that you don't have to do it every time. Okay. The lead in, lead out on this. We got our lead ends coming straight in from the end. You don't really have to worry about it because it's going to start and it's going to follow the whole profile. It's not trying to go in and gouge into roughing passes. So it shouldn't have any collisions there. You shouldn't need to change the angle. Lead out, it's going up and away. It's going 130 pass with the finish pass. That's okay. I'm not too worried about making sure I'm down the extra 15 thou past the end of the part. So I'm going to hit OK. I'm going to check out. There's our finish pass on the part. Yeah. What's that? What's that? This? It's a tool nose radius. So the blue line represents the perfect point on the tool. The tool has a nose radius. So it's calculating it. This is where that's going to be, but the dotted line is actually what's cutting. Okay, so what you got to think about is if this tool had a perfect point on it. Let me draw kind of a makeshift turning tool here. Let's see here. I know what answer it is. I'm trying to think of what angle I'm gonna put here, but 265. Line up this way. It's gonna be 265 down. That one's sitting at 85. So 85 minus 55. Okay. So if I can give you I want to just give you a visual on this. So if I put this kind of right there with a perfect point on it, that's where it would be cutting. But this insert, or this tool, we know has a 30-second nose radius. All right, well, let's put that radius on there now with it drawn right there. A little further back than I would have expected it to be, but that's kind of what. It's a little further back than I would have expected it to be, but that's what's happening. It's the nose radius of the tool that's not being represented there correctly. And that's, I always tell everybody, don't get fooled by this here, because it's truly the profile. So the dotted line is what's actually getting cut. This is what the program path is using tool nose comp. So, all right. I probably didn't draw that right. That's why I didn't do that correctly. 85 degrees.
Yes.
Looks way too aggressive, even for a 55 degree tool. I'm struggling with this insert drawing.
It's 55.
I know it's 55.
I just said that, Brad.
I'm struggling. It just looks way too. Maybe it's just because of the size that I'm drawing it. Makes it look so big. You know, I think if I create a circle tangent and I tell it it's got a 0.375 diameter, that would be the inscribed circle. That still doesn't look too big for it. That's crazy. Hey, what if I did this? I don't know why I'm sitting here doing this. What if I did this? What if I just played it in backlot? I'm sitting here trying to draw stuff that I'm not even an artist. Oh! There you go. Now you get it. It's basically, it's compensating for, you know, if this came down and this came down and met there. So, all right. Now, here's the next question. If you were machining this part, what would you do next?
Part it off.
Okay, you're going to part it off before you put threads on it?
Groove off the thread leaf.
Would you cut the thread relief groove next? One way to think about it. So what if I told you that I wouldn't do the thread relief groove next? I would cut the threads next.
I would ask.
Because here's why. Because I'm going to use the same tool, and this is the way I think about stuff on the CNC. Does this have to be there before I do this? And if I can eliminate a tool change, I don't care if it's the mill or the lathe, if I can eliminate a tool change, I'm going to eliminate 10 to 15 seconds out of that program. If my rapids are turned down, that could be, 30 seconds on some machines. Some machines have slow tool change. If you have it on a mill, if you've got an umbrella tool changer, that thing's got to go all the way around to do a tool change. It's not like our side carousels where it just flips the tool down and they're already pre-staged and ready. Some lathes have very slow turret indexing. Some lathes are real quick, like our TM8s. Our TM6s are, they take a second. The TM8s, it'll spin around pretty quick and scare you sometimes. So, that being said, the relief groove is for nothing more than whatever this part's going to screw into so that it'll bottom out, right? It doesn't do really anything for the threads themselves. It's a relief groove so that when you get to the bottom of the thread, it ends with a full thread and it doesn't, basically tie up the threads at the end. That's why we create relief grooves. So, we're going to go ahead and thread it, and then we'll come back in after the threading and we'll groove it, and then we'll part it off. Make sense? And like I said, it's just so you don't have to bring the parting tool in, then the threading tool, then bring the parting tool back in, the grooving tool. So, let's go up to our turning, and this one we're going to pick our thread tool path. Notice it didn't even have us chain anything. That's because everything is contained within the toolpath itself. We tell it where's the threads, what size the threads are, where they start, where they end, and then it will generate the toolpath around that. You're going to select from your library a right-hand threading tool. It should have just a couple options here. 9797 is the one you're going to grab for me. OD right-hand threading tool. Notice this tool has a 14 thou nose radius on a threading tool. Most of ours have about a 3 thou nose radius. So when you're cutting small threads, I wouldn't want to cut a 1/4 thread on a part with a 14 thou root nose radius. You'd have to cut the thread depth so deep to get the root to where it needs to be, that your thread width's going to be so wide you're not going to have a very good thread, are you? And that's why they make different inserts for different size threads. So whenever you are doing this, we're going to use this one today. We're just going to grab it and hit OK. But let's right click on it and hit edit. And the only thing I'm going to edit is this C, the nose radius here. Make that 4 thou instead of 14 thou. We're just going to make that that tip radius a little different. That's really what you see most often in there we go. With threading inserts, like these are top notch. Here's some lay down type inserts like what we use. Let's just let me see if I can just get a bunch of Seco inserts up here on the screen for you. There's 1,831 different Seco threading inserts on MSC's website. Okay, all kinds of different ones. So like here, they tell you when you get the inserts kind of what the max TPI is of them. So like here they say this one's a max TPI of 14 threads per inch. Quarter-inch inscribed circle. Now, does that mean I can only cut 14 threads per inch with this one? No. That's basically just saying, hey, this is the limit of this one. Now, that means pretty much anything from 1 to 14. Now, the thread depth could cause, if I'm cutting really big threads, some of these inserts may not be able to get to the thread depth that I need to get to cut the deeper thread, and I'll have to get a different type of insert. But usually if I'm trying to cut something that is a higher TPI, meaning like 14 and above, I'll come in and I'll say, hey, I need to limit this to, I need to be able to do, what are we doing right now? 10, so that won't really apply. I need to be able to do 20 threads per inch. I'll apply that filter. Okay, and we'll go into this one. I'll see if it gives me. If it doesn't give me what I want here, I'll look in Seco's website, but I think it might have the info here. Okay, so here's 6 thou nose radius on this one. All right, 6 thou nose radius. It does tell you like what your max depth is. I don't know that it says here, but it does on Seco's website. There it is. Cutting edge to theoretical edge length. That means you wouldn't be able to cut anything that has deeper than a 31 thousandths thread depth with this insert. All right. I'm showing you this to tell you that not all threading tools are the same on the CNC. Like out there, you know your threading tool is your threading tool, right? It's your threading tool. Not all threading tools are the same. Make sure you have the right one before you start trying to cut threads. I've had people, believe it or not, I think it was on that lightsaber project when Austin was making it, fighting threads, couldn't get the threads. Came to me, he's like, I don't know what's wrong. I looked at his program, like everything's right. I don't know what's wrong either. Like everything looks good here, and I look in the machine, I look at it again, and somehow he had gotten his hands on a left-handed boring bar threading insert. So when you're cutting on the inside of the part, the threads basically, or the inserts backwards to what a right-hand OD insert is. But he had got one of those inserts which fits into the holder just the same, which is kind of a bad engineering thing. But the problem is the cutting edge is on the wrong side. So he was trying to cut the threads on that thing, on the inside of that thing, with the bottom side of the insert. And that's why we were getting such a nasty, it was cutting because it's carbide and aluminum, but the bottom side doesn't have all the cutting geometry correct to give us a good cut. And we couldn't fit, like we fought it. Like that was, what was that, 2 years ago or so, but like I remember him coming, he's like, I've adjusted this like 25 thousandths and it still doesn't want to screw together. It's probably why it's broke now. He probably overcut the threads too deep. But anyhow, it's important. If you don't know, ask. If you don't know, hey, is this the right insert for what I'm doing? Just ask. Okay. All right. Back to here. We're going to cut 3/4-10 threads. I'm going to set this to inch per revolution on the lathe. So on the mill we calculate our threading. Everything's inch per minute on the mill. So we got to take our RPM divided by TPI to get our feed rate, right? You can do that on the lathe too. You can take your RPM divided by TPI and get your inch per minute feed rate. It's the exact same on the lathe. Okay. But I have the option to do inch per revolution on the lathe, so I typically do inch per revolution, so it just takes 1 over TPI and gives me my feed rate. Right now it's 50 because the TPI on the next tab is 20. As soon as we change it to 10, 1 over 10, it's going to do 100 thou per revolution to cut these 3/4 10 threads. I'll set my max RPM at 1200. Now you also notice how this is grayed out on the threading. Threading is a set RPM. Okay, when you thread, you're just telling it this is what I'm going to run my RPM at. And obviously, you know, when you think about constant surface speed, the reason you use that is because as you transition to different diameters, the RPM is going to change a lot. Well, with threading, you're not making huge diameter changes. You know, at the most, it might be 70 thou on a really deep thread for the thread depth. But so they just do a standard RPM. So I usually just leave it at 200. I almost never change it unless I'm making, like, trying to speed something up cycle time wise, like in industry even. If you're making less than 100 parts, I'll usually just leave it at the standard 200 and let it run because it'll cut a really nice clean thread, and it doesn't really speed up threading that much, and it wears the insert out a lot quicker when you speed it up. You know, this is one of those things where unless I was making millions of the part, I probably wouldn't push it. Thread shape parameters. So here, like I said, if you change your lead or your threads per inch to 10, and you go back to the toolpath parameters, you'll notice that your feed rate just changed to match 1 over TPI. So 1 over 10 is 0.1. You notice that we 60 degree, 30 degree thread angle. That's a standard thread, right? Now I could go into my machinist handbook and I could get the major diameter, get the minor diameter nominals, get the thread depth nominal, and I could do that all in my machinist handbook. But you know, it's like anything else. Why would I work harder when I can work smarter? Up in the right corner, we have a thread table. So I'm going to select my thread from the thread table. Now, the thread that we're going to use is the unified UNC UNF. Okay, so that's what I want you to select. That's your standard coarse and fine threads. You know, unified coarse or unified fine. And then you'll go down in the chart here and you'll find the 3/4 10 thread. And when you pull that in, it will populate all that with the correct thread information. Now these numbers, these are the nominal numbers that would be in the machinist handbook. So just for cross-reference, sometimes people like me to prove it to them. Sometimes I don't, but I'm going to do it anyhow. If I open up my 27th edition, I've got an older copy on PDF here of the machinist handbook. Okay. And I go to page 1732 just because I know what page it is for threads. Honestly, I would say of all the times I've opened the machinist handbook, 95% of the time I'm going to look at thread information. Like this, and I just got a PDF. I don't have a hard copy of it. I think I do somewhere, but I don't know where it's at. I just use this PDF copy. All right, and I'm happy to give this to anybody. Okay, it's just a PDF copy of this edition. Threads haven't changed. If I go down here and look at the thread charts, and I go to 3/4 10. Closer, there we go. I see my major diameter, you know, it's pulling in 750 for the major. Then we get over here for the minor, it says 629. This pulls in 641. It's adding some allowance there. Now, I always tell everybody this. I realize, and I'm going to uncheck this allowance over here. I don't want to add any extra here. I always tell everybody this. I go right off the thread table in Mastercam, and I know I'm going to have to comp the thread in when I get to the machine. All right, I know I'm going to have to probably go, usually it's like 10 to 15 thousandths to get my thread on size for anything a half inch or larger, and then it's about half that amount for anything half inch or lower, but you're always making some thread adjustment, which is, I'd rather the thread be cut too small to start, and then I get to dial it in so I get a good thread fit, just like out there. Once you get the thread fit, it's there, but I want to dial it in. So I usually go right off this chart, let it pull in that number. I know that minor diameter's bigger than what it's probably going to end up being. The reason I tell you that is this value right here, okay, for these external threads, 629.1. All right, I'm a little different out there. Most stuff's pretty calculated on the CNC side. Not that it's not calculated on the manual side, but I consider what I do out here a little more calculated a lot of times than just kind of go a little more and check it out and see what's up, see if the nut fits. Got a thread pitch mic. What I will do is I will look, and I know my thread pitch needs to be somewhere between 683 and 674. So I want to be about 678. I'll measure my thread pitch with my mic. If I'm 680, I'll make 680 is a little close. If I'm 688, I'll adjust that thread 5 thou. I'll recut it. I'll measure it again. If I'm on track and it's cutting correctly, and I got 5 thou more, then I'll go 2.5 thou. When I get within about 1 thou, that's when I start trying to fit my gauge on there. Okay. Has anybody ever used thread gauges before? Like go, no-go thread gauges? Yeah. So a lot of times, whether it's internal or external threads, and I always laugh when I had one of the guys I work with, we were cutting internal threads with a tap, and he bought thread gauges for it. I told him, I was like, Matt, it doesn't matter. I said, once that tap cuts the thread, we can't adjust it. Like the tap's either still good or it's not. I said, I don't know why you bought the go and no-go gauge. Basically the go is if it goes in, the no-go, if the no-go won't go, if the no-go won't go, that means the tap's worn out. It's time to put a new tap in. You can't make radius adjustments on tap, but it's all right. They were only like $60-something a piece. So anyhow, like I said, these things I leave where they're at. Now, in position for the tool, right now, it's going back to 1 inch is where the shoulder is. Let's put 5 thou back on that to keep it from that shoulder. Okay, we're going to leave it 5 thou shoulder to shoulder. That way it goes all the way into the relief groove. And we'll see what it looks like when we generate. Okay, we're going to come back in and change that, but I want you to see it visually so you understand that you should always watch out for this stuff. Thread cut parameters up here. Everything should be good here. We don't have any angle. We're not cutting a tapered thread. We're not going across the center line or anything like that. Okay, code format, longhand. I used longhand code post. We don't have the can cycle built into our post for threading. It's an option. You could have that done. You could have your post processor company, your Mastercam, or whoever your software reseller is. You could say, hey, I want to use can cycles. That way at the machine I can make adjustments to my threads. I don't, because basically if it posts out longhand code for the thread cycle, which when I say longhand, meaning it posts out every next depth of cut, I can come back in here and make the adjustment, and I can take it from this lathe to that lathe to this lathe, because the can cycle is going to be different between whatever lathe you're on, brand wise. If you're on different brand lathes. Now, if you have all Akumas, if you have all Haas's, if you have all Hercos, if you have all Mazaks, well, then maybe you do that, tailor it a little differently. But this is kind of the one size fits all option. Calculate depth cuts from equal area or equal depths. What's that mean? Well, equal area means contact area on the insert. Obviously, as you get deeper into the thread here, and this is kind of a good illustration of it, more of the insert's engaged in the cut, right? Equal depths is just that. 10 thou, 10 thou, 10 thou, 10 thou. You get to tell it what you want the depths to be when you program it. So if I tell it equal depths, and I have it on 5, that means it's going to take the thread depth divided by 5, and that's going to be the depth of cut. If I set it on equal area, and I have this set on 5 cuts, the first cut is going to be a little deeper, and then as it gets further down into the thread, it backs off to a lighter cut because more of the insert's engaged. Just like when you're cutting threads out there, as you get closer to size, you're cutting a lot less, right? I don't know what's your max on threading out there. It's probably been a while since anybody's cutting threads, but
About
5 thou, and then you get all the way down where you're cutting like 1 and like almost nothing, right? So that's what it does. It just backs it off as we get down in thread. Same thing here. I typically leave that on 5, the default number. I've had real good luck with that, cutting most threads in soft metals. What you would want to make sure you look at is if you're cutting a deep thread, the material, it's going to give you parameters for that insert. It's going to say, hey, don't cut anything deeper than 10 thou. Well, in that case, I might have to, bump up the number of cuts so that it reduces the first cut depth a little bit. Now, one thing I always also do is I add a second spring pass. So spring passes are your 0 passes. What?
Huh?
What? You're shaking your head like you didn't like the spring pass.
I know.
All right. So we're going to do 2 spring passes, 2 0 passes to clean that thread up. Did you have your hand up? You guys are messing. You just had your hand over here. He's over here shaking his head. All right.
I have my mouse.
Stock clearance. This stuff down here, I don't normally mess with. You can like what we did. We programmed it to go all the way back to the face minus a 5 thou. You can also program it to just go to the end of the threads and then add some overcut to get into the relief groove. I usually don't. I leave these numbers zeroed out unless in the anticipated pull off. If you want it to, let's say you do want the thread as it gets to the end of the thread, you want that thread to tighten up and bottom out on the thread for some reason, whatever it may be. Maybe as it's going into the hole, that's going into the hole and you're going to lock it in and jam it in that hole, and you're lock tighten it in, and you want that thread to get tight at the end. You could do an anticipated pull off where when it gets to the end of the thread, it starts reducing the cut depth so that the threads get tight at the end. You got options here. I usually don't mess with any of this stuff. Very rare that I mess with anything that's down here. Obviously, lead in angle, it's going to do the same thing we do with the compound rest out there. Every depth of cut, it's adjusting like this. It's going at that 29-degree angle as it goes in. It's not just going deeper straight into the cut. It's going at that 29-degree included angle. Okay. One other thing, just kind of see here. Last cut, 1 thou. So the very last cut it's going to take is going to be 1 thou. So as it calculates the depths of cut, it knows the last one's only 1 thou, so it's got to kind of figure everything in between that to that last cut to make sure it's accordingly. If you ever want to cut a double lead or a quad lead thread, it's real simple. It's right here, checkbox, multi-start. If I tell it 2, it'll cut a double lead thread. Okay, it'll cut the thread, then it'll reorient and cut 50, halfway across the part and start the thread again and do a double lead. If you want to do a quad lead for any reason, you can do 4. I've never cut a quad lead thread personally. I think it'd be kind of cool to do it sometime, but I never have. I have cut some double lead threads once or twice on industry stuff. But most of the time, it's just going to be a single start point. So usually that's just unchecked. All right, green check mark. Boom. See the problem? Crash, bang, boom. Okay. So this is another reason it's pretty important that we set the tools up correctly in here, because it gives us true verification of what's happening. It lets us know that, hey, you just notched out the shoulder of this part because you ran the tool into it. You can tell why, I hope. Maybe you can't, but if you look at it closely, you notice that basically it's programming the distance to the thread point, right? Well, if that insert's an 1/8 inch wide and goes down to your thread point, it's going to go. So a lot of times what we will do out here, we'll set the tool up, we'll touch off the leading edge of the insert, and then we'll basically subtract in Z, half the width of the cut, the V, basically the thread V. Okay, so we'll look at it. It tells you what that width is on the insert information, and then we'll move it over and Z that amount to the thread point. Now, that doesn't really do anything for this right now, but we can fix this very easily. If I go into the parameters here, and you can just watch me, you don't have to, unless you want to get in here with me. All right. If I come in, and I can do some simple trig to figure this out, or what I usually do, because I'm lazy and it's not that critical that I make sure it's exact. Thread shape, I'll set my in position. So if you click on in position here, I usually just pick the middle of my relief groove, and then I hit OK, and then I look and see whenever it verifies it again that, yep, it's going far enough, and it's not hitting the shoulder now. It's cutting a thread. It's going to cut the same thread all the way through here because the pitch and the start point's the same. And there's the thread. It doesn't show you in the stock preview all the threads. It kind of gives you a start, and then it kind of goes simplified, and then it gives you the last 2 or 3. But if you watch this in Verify, and I didn't say beforehand, that way if it crashes, you still have it. But if you watch it in Verify, it does show you in the Verify graphics the actual thread cut.
Yes. What are those gray V's in the wireframe?
That's the thread profile. It just showed. That's why I was just saying. It just shows you the first couple and the last couple, and then goes to simplified. So if I watch this, what just happened? Anybody else's do that?
No.
Just me.
No, mine did it. I don't know.
Oh, I think you have a taper on over the threads.
I don't think it was the threads. It was like the turning tool or something.
Is that what it's supposed to look like?
Yeah. Yours did that too, Jack?
Sure did.
Nice job.
It means I follow his instructions better. I don't know. Yeah, I'm following. Do you really need a thread?
I think it's because it didn't. I think it didn't retract between that second rough and this. I'm gonna look here and see if this fixes it. But all right, let's slow it down and see if I can see where it's happening at. Let's find the crash. Let's find the crash. Red's bad. Red's blood. Parts bleeding. All right. So here we go here. There's the rough in there. There's the rough in there.
So pretty.
Slow down a little bit. There's that one. There's that one. I think right here when it tries to go back to the finish pass is where I think it's happening. Yep, right there. So it's not retracting for some reason here. Let's see if I can. See in the roughing here if something's not. Okay, doesn't make much sense.
Isn't that on your finishing pass?
What?
Is that not on your finishing pass?
It's doing it as it retracts to go back to the finish path. So when it goes from this toolpath to this one, it's cutting. It's trying to go straight over to here without a retract move. Now, I really hate to do a forced tool change there, but it shouldn't have to. Well, let's do this. Sometimes just regenerating all the tool paths will fix it, maybe. Sometimes regenerating tool paths fixes it.
So if you ran that before you fixed it,
It would crash. That's why verify is important. So that's why it's I think it's really silly. You know, I'm just gonna tell you this. I think it's the silliest thing on earth when we crash parts out here, or I crash parts out in industry, because I do it too. You know, I'm gonna sit here and tell you, get it together.
now it's doing that. Now that I was going. That was I was going based off of this one first. And now I'm going off of this one.
Now watch it. All right. Hey, you guys are adults. Come on, quit it.
That was
All right. So like I was saying, I think I'm the biggest idiot when I do it. Okay. And I continuously tell students like, hey, please don't do this in industry. Don't make a fool out of me. We've got to verify screen. I don't care what CAM software you're in. They've all got verify screens. If it's not verifying correctly, then I'm not taking it to that machine. I'm figuring out what's going on here. It might be a glitch like that right there. For some reason, because when I created those toolpaths, it didn't create the retract position. Okay, it didn't retract up and over. It basically is trying to go straight from the end of this toolpath right here and then come straight down and across there. You know, something in the batch processing in the background didn't happen. So what did I do? I just selected them all. I regenerated them, let them all try to recalculate, and then now it verifies correctly, and I feel much more confident about it. If I would see that red on my verify screen and I did it correctly, you know, I'm doing it. Now, I'm not going to lie to you. I can't tell you how many times I've been at the machine and had to hit the button, and then I go look at Mastercam like I'm an idiot. Why didn't I run this through verify? You know, I'll see where there was a retract move that didn't go up high enough, and it runs an end mill across the top of my part. You know, I do it not all the time. I shouldn't say that, but I've done it enough times to know better. And to know that this doesn't take very long to do, but I just get in a hurry and I don't run it through. Okay. All right. Threads are good. Now we're going to do our relief groove. So this one we're going to use the groove toolpath. We're not going to import these. We're just going to use fresh ones up here. Just kind of go through the run of it. So we're going to use the groove toolpath. For this one, you could do pretty much any of these options. I always use chains. I always draw the groove and then chain the groove. That's me. But here's what I want you to look at on this. So we're going to create it with the chain, and then we're going to delete it and recreate it, okay? Because I want you to see it both ways. So hit OK. We're going to create a partial chain, so we're going to pick this line going down into the groove and then this line going up out of the groove. Okay. And we'll hit OK. Everybody's chain okay? All right, a few that were fighting chains there. All right. Okay. All right. Select the 1/8 inch groove tool. So in here, there's a 125 wide right hand groove default tool. Not too worried about any of this stuff. We'll just kind of get you in the motions of max spindle speed 1200. I'm going to say I'm going to cut relief groove. Groove shape parameters. Well, this one's coming straight in. You know, the angle's usually what we're looking at here. Notice all this stuff's pretty grayed out, you know, because it's looking at the geometry too and kind of saying, okay, you're probably not going to need any of this stuff. But, you know, typically we can adjust the start and the end of the contour right here. That might come in handy in a second. We'll find out. Groove rough parameters. I rough towards the chuck. I want to keep my part as rigid as possible. So sometimes you might have a groove that's, you know, 1 inch wide. And if I start going bidirectional and I start in the center and I'm going this way and this way, as I'm getting further from the chuck, the part's getting weaker, right? Depending on how deep that groove is. So I always work towards my fixture, towards the chuck. I don't see any benefit unless they can sell me on something that the bidirectional is a better option as far as tool life or cutting parameters go. I guess I say that. I guess it makes sure you're using all of the insert, you know, because when you're going negative, you plunge with the whole insert and then you're just using that same 75% as you go over. So, you know, insert life maybe in certain situations, but in aluminum, it's hard to wear out an insert when you're cutting aluminum. Usually it's crashing the insert's what kills it. Forgetting to turn coolant on kills the insert. You know, loading it up with built up edge. You're not usually breaking down the carbide insert too much in aluminum. All right, step them out. 75% of the tool widths, kind of standard there. The only other thing you should have to do, that back off percentage for the default tool, that's 5% back off. And then the stock to leave, this tool's got a 10 thou nose radius, so let's leave 10 thou on the floor and the walls. All right. None of this stuff's gonna matter. Yep.
Since it's just relief, why are we leaving stock mags?
Why are we? Because, well, it's gonna do a finish pass too. Because it's gonna come back in and do a finish pass on this groove here in a second. Now, it's a good question. If it's a relief groove and it's got plus or minus 20 thousandths crazy tolerance on the relief groove, which is not doesn't never happen, but it's rare, I think, for most parts. Even things that don't matter, they typically still hold the intolerance on them. depending on who you're working for, especially on government and healthcare and medical type stuff and aerospace stuff. Even the relief groove is going to be held to a tight tolerance. But you could take it right to size, and then you could shut off the finish pass, if it was just something roughed out. All right, so all this stuff we're going to leave alone. Everybody good here? What's up?
I do have a question about the groove walls.
The what?
Groove walls.
Okay.
So, when would we use that exactly?
So if you had a groove that had tapered walls in it that you're cutting out, this one, it doesn't matter what it's on because it's just a straight in, straight out groove. But if you did have a groove like the picture there that looked like this, it's got tapered walls. If you leave it on steps, it's gonna, as it roughs it, it's gonna leave real roughed edges in here. Okay, and then when the insert comes in, it's gonna try to clean that out all at once. So if I do have a tapered wall groove, I always leave it on. I put it on smooth, so it creates basically just like the turning. It creates an overlap. So as it roughs it, it'll basically take it all down to here, and it'll rough these out. That way, you get a consistent 10 thou all the way through the finish pass. I don't know why you wouldn't. That's my thing on it. I don't know why you would want steps. I don't have a time that I can tell you that I've ever left that on purpose on steps. There's times where I've done it just because I forgot to click it, but if I have tapered walls in my groove, I'm usually always making it smooth, and you can control the overlap amount when you hit parameters there. You can come in and tell it remove groove steps, and it'll tell how much you want to do there.
Just like on the turning?
Yeah. Okay, let's go with finish parameters. I'm gonna leave everything here just like it is for now. I'm gonna come down here and tell it 10 thou because the nose radius is 10 thou, overlap between. It's gonna go 10 thou on one side, 10 thou on the other side, which should give us a flat floor in the bottom. Okay. All right. Let's go ahead and click OK and let it generate this. It should generate fine with no collisions or anything. I want to watch this. I want you to watch it with me up here. You can backplot it on yours too. But I just want you to see kind of what it's going to do. And this is kind of what I was leading in with when I said we're going to probably change that tool path if it ever gets here. Come on. Where's that?
There it is.
Okay. So as this comes in, like I said, it's going to start over there and work its way back in Z. Once it gets it all roughed, it's going to do a finish pass from this side. Then it's going to go all the way up here and do a finish pass all the way down that side. Now, all of that's already finished because the turning tool got all the way to that face, right? So that's more than I need. So let's redo this. Hold on a second. This might cause some dirty tool paths. It did. That was stupid. I have to rechain. Give me a second. Always bad to delete something when it tells you not to. Rule 1. I'm back. Okay, so, oops, not back. Not back yet. Let's fix this groove situation. All right, now I'm back. Okay, so here's the thing about the lathe that I always try to kind of make. There's a lot of ways to do things. Most of the time, keeping it really, really simple, even on the mill, is the best option. There's ways to get super technical and go into the parameters of toolpaths and make them, do things you want them to do. Like even this one. Like, there's 3 ways I can get what I want to happen that I can think of right now to get it to not start this finish pass way up here and cut all this air until it gets down to here to do this finish pass. There's 3 ways. One way is going into this toolpath and the parameters of it, and you need to do this one with me. So go back into the parameters of it. If I go to the groove shape parameters, what I can do is I can tell it, hey, on the end of contour, which is this line here, I want to tell it that the contour, I want to shorten it to where it's down here. Now for that, it takes a little bit of math, doesn't it? Because when I click on that, it just end of contour, and it pops up the extend shorten. Okay, I'm going to tell it that I want to shorten it, and then I get to do a little bit of math. So what I'm going to do is this. I'm going to say I want the distance between 2 points. I'm going to click up here, and I'm going to click down here. So that's 44 and a half, or you do the length of a line there. And then I'm going to subtract the relief groove from it. The relief groove on this was a 16th, right? 16th deep. So I'm going to subtract the 16th from that. And I'm going to shorten that 282 thousandths. I'm going to check mark out. I'm going to let it regenerate. Oh! And then I get a collision. What's 9 out of 10 times what causes collisions? With grooving. I talked about it the other day. Remember what we had to go in and change on the finishes of the grooving on that other part? The vector angle. So I'm going to ignore the warning here and let it go ahead and crash out. You can see here what it's doing is it's trying to do this finish pass, but it's got for the second pass, it's got a start angle coming this direction, which gets it back here inside the part. So I'm just going to go change that vector angle for the second finish pass. So I go to groove finish parameters and go to lead in. And the first one's coming from out here, so that's safe. The second one is coming from back here, which would be like in the chuck or in the part. So I could either make it straight down, but even straight down is still going to give you like a warning, even though it's not technically touching, but it thinks it is because it's coming over to where the start is. I would set this to basically come in from away from the shoulder for the start of it. And then if you regenerate, that collision goes away. So that's one way to get the relief groove to cut just that lower area that you want it to stay in without all that extra movement. Now guys, I'll also tell you this. If I'm only cutting one part, I don't care if it takes it 6 extra seconds to start up there and then work its way down that wall to come in and finish out the groove. It took me longer to go in there and fine tune it there than what it would to do that. Now the other way I could do that, and this is typical for me, I would create a new level, and sometimes if I'm not getting the results I want, I'll create a new level and I'll draw just the groove that I want to cut as wireframe on that level, and I'll chain that chain. Or your other option okay, would be, you can just watch me here, would be like a 2-point option. And then I would just pick like this top point and this bottom point. You notice how it creates like a bounding box? I say, here's the groove. I go in, and most of this stuff should have auto-populated. When I get in here, you notice it's giving me a whole bunch of stuff it wants me to plug in. Like if I have any radiuses, which I'm just going to leave all that stuff alone. Let's say use stock for outer boundary. I'm going to leave all this stuff alone for now. It's going to give me bi-directional, but that's okay. I'm going to come in here, tell it my 10th thou overlap. My lead in. Change the same. Error making groove pass. Why does it have an error? Well, because it doesn't think there's any material there. If I deleted the one we've got, it should look identical to this one. I hate to delete this one, so let me see if I can move after, and then let me see if I can regenerate this one. There we go. So there's the one I just did using the 2 points. Now this one won't regenerate because, oh yeah, it did. I'll be done. Well, because I had the chain. That's weird. Wonder why that other one wouldn't regenerate a second ago now since that one is. They're both using stock recognition, so it's kind of weird that the other one didn't do that, but I don't need this extra one. All right, everybody's groove okay? All right.
Mine's like retracted all the way up.
Groove shape parameters. So you stock for outer boundary. Still got a big. So you extended it instead of shortened it. Just in the contour right there. Nope, back. Just in the contour.
Yeah.
On that, you got it set to extend instead of shorten. There you go. Okay. All right, we're going to part it off. We're going to create a chamfer on the back edge of the part with the part off. Okay. So we're going to select the cutoff toolpath here. Now, the boundary point we want is right about here, but I can't just write about it. I can't just be like, oh, that looks good, can I? Not if I want to be correct. But I want that cutoff point to be the outside of the part, the furthest back. So we've got tools in the auto cursor menu to pick that point, that exact point where this edge and this edge intersect. So if I go up here to auto cursor, I can pick the intersection, click on that, and then you just pick those two lines, and you notice it kind of snaps and shows us that intersection point that it's going to use for the cutoff point. On the lathe, you're going to have a lot of parts that have chamfers and radiuses on the back side. Okay, but you don't want to pick the point at the bottom of the radius because you're going to have material up there that you got to cut away, and you want it to use that stock as recognition for the outer boundary. So you're going to use that intersection to select that point. Okay. All right. We're going to do a max spindle speed of 1200. We're going to tell it down here that we are going to chamfer and part off workpiece. In the cutoff, I always use the stock recognition. Go from the stock, recognize what's cut. So I always check mark the from stock buttons up here. I'm gonna set the X tangent point to like 50 thou. Wait, it'll part it off down to basically 100 thou diameter, 50 thou radius. That way it doesn't. If you leave that at 0, it'll part it all the way off, but then the stock preview disappears off your graphics window. And even in the draw, like if you go to verify and you part it all the way off, the material disappears, like just like if it would have dropped off in an actual part off, it's gone. So Usually I always leave a little bit here, and then if I do want it to part it all the way off, I'll bring, I'll adjust that toolpath in at the machine. So, other than that, we're right here. We want to create corner geometry on the back of the part. We want to create a chamfer. We want the chamfer's size to be a 63 thou. Now you notice there's select chamfer line. I could go out here and pick this line and pull it in from the chamfer line. I could plug in, a height and a width and a different angle if I wanted to. I can do pretty much anything I want to do there. It even gives you the option to put a radius at the top and the bottom edge of the chamfer. I usually leave that 3 thou radius there. Most parts you get, it's going to say break all sharp edges. So a lot of times I'll use the tools within the tool paths to break all the sharp edges. There's break all sharp edges options in the tool paths to do that. Or you could draw it into your part. Draw it into the geometry, and then it'll cut it that way without using the tool path options. I'll hit OK. I should be able to hit OK down here, and I should see a part off. Now sometimes we turn back far enough that we don't have to worry about it. We cut this extra amount back so we didn't have a clearance issue here. But sometimes if we don't turn it back that far, you'll get a little warning there. Will give you that collision warning. Okay? If you get that collision warning, you have the option in the parameters of that chamfer to create a clearance cut. And I usually do that. Like I'll come in here and tell it from stock, and I'll do like a 10 thou clearance cut for the chamfer on the back of my part, or the radius on the back of my part. And that typically will take care of that clearance issue where it's getting into the stock. But in this case, you should have it turned back far enough that you didn't need it. All right. That's the lesson for in-class part. Hit save on that. I'm going to pass out the assignment part, and you guys can all get to work. You can, if you're dilly-dallying around, you might as well be working on this homework. Pass those around.
When's this homework due?
Thursday. Okay. On that part, it's got 2 concave areas. I'm anxious to see how you try to approach it. Okay. All right. Questions? All right.